Factoring of polynomials, part 2. Perfect square trinomials, difference of squares, completing the square, and the quadratic formula. Perfect square trinomials are basically when you have a binomial that is squared. For example, in example 1, I have the result of x plus 4 squared. Example 2, x minus 9 squared. If we multiply these out, such as through FOIL, we would get x squared plus 8x plus 16, which is the same as x plus 4 times x plus 4, or x plus 4 squared. Same as x minus 9 squared. That's simply x minus 9 times x minus 9, which, if you multiply it out through FOIL, you get x squared minus 18x plus 81. And what I want you to notice here is there's a general pattern for you to recognize when you see a perfect square trinomial. We have an a and a b component, and it's squared. When it's multiplied out, the a is squared, the b is squared, and then you got to realize what your a and b are, and you multiply times 2, 2ab. On example 1, for example, when we have right here the a squared plus 2ab plus b squared, my a squared is my x squared right here, which means my a equals x. And then I got my b squared, and that is 16 here. Well, if b squared is 16, then the square root of b, or just b by itself, is 4. And then using the formula a squared plus 2ab plus b squared, I get x squared, and then plus 2 times a times, 2 times x times 4, which would be 8x, and then b squared. 4 times b is 4, so b squared equals 16. Again, it's a perfect square trinomial. Similarly, a squared minus b squared, which is, like I said, a minus b times a minus b. In this case, my x squared minus 18x plus 81, we can prove this by x minus 9. My a equals x as before. My b equals negative 9. And then when I put a squared minus 2ab plus b squared, if a is x, then a squared is x squared. X squared minus 2ab, which is 2x times negative 9 times 2, which is negative 18x. And then my b squared equals negative 9 times negative 9, which is plus 81. So as I've shown here below, this is the whole area component right here. And basically, you got to figure out, the most important thing you got to realize is when you're seeing that x squared, that's the a squared. So your x is your a. But more importantly, when you see that b squared, you're looking at 16. You got to remember b is the square root of that, or 4. For 81, it is going to be either 9 or negative 9 for the b. And we have to be careful with this, which is why you look at, are you adding or are you subtracting? And this is an a minus b squared or a plus b squared. And that's why you determine which formula to use. Either this one if it's plus, or this one if it's minus. I got some examples here. Determine if x squared plus 12x plus 36 is a perfect square trinomial. So my a squared is x squared. So that means my a equals my x, as before. And then 36 is my b squared, and the square root of 36 is b. And it should be 6 there. So the square root, the whole formula is a squared plus 2ab plus b squared. And this is a plus. They're all pluses here. So I'm going to go with this formula right here. My middle term, which is 2ab, which would be my x, which is my a, my my b, which is my 2, and then times 2. X times 6 times 2 is 12x. So it's going to be x squared, which is my a squared, plus 12x, which is my 2ab, plus 36, which is my b squared, which is 6, which is x plus 6 times x plus 6. Perfect trinomial with a minus, where I got a squared minus b squared, where I am using this version. Again, let's figure out my a and my b. I've got x squared minus 14x is 49. Well, this is my a, my x is my a. So this is going to be right here, my x. 49 is my b. Now, I don't know if it's plus or minus 7. B squared. 49 is my b squared. I don't know if it's plus or minus 7 for the b. It's a minus, since it's a squared minus 2ab plus b squared. So it is going to be negative 7, as I said here. So 2 times a times b, and that should be negative 7, as I put over here, it's minus 14x. 2 times negative 7 times x is negative 14x. There's that middle term. And then as before, 49, 7 squared is 49. So, x minus 7 times x minus 7 is x minus 7 squared, and that factors out to x squared minus 14x plus 49. Now, difference of squares. This is where we have two perfect squares, but they're subtracted. It's simply an a squared minus b squared. We're not had no parentheses here. It is a binomial, but it's a perfect square minus a perfect square. For example here, 64 minus x squared. 64 is a perfect square. 8 times 8 is 64. And then x squared is a perfect square. X times x is x squared. But when we factor this out, it's actually pretty simple. A squared minus b squared will factor out to a plus b and a minus b. Because when we subtract them out using FOIL, we notice a times a is a squared. A times negative b is minus ab. B times a, which is ab again. And then b times negative b is minus b squared. But these two cancel each other out. Minus ab plus ab. So our left is a squared minus b squared. You got to recognize that they're both squares there. And you don't really have to do any type of factor at all. As I said before, 64 minus x squared. Well, if my a squared is 64, that means my a is 8. 8 times 8 is 64. My b squared is x squared. That means my b is x. So this is simply going to be x minus 8 and x plus 8. X squared minus 144 in example 2. Let's look at this one. My a squared is x squared, so my a is x. My b squared is 144, so my b is 12. Because 12 times 12 is 144. And I'm just going to put these in the a plus b and a minus b, and that's simply going to be x minus 12 and x plus 12. And that is it for the factoring. Now, sometimes we have to complete the square because we don't have a complete number, but we can use the perfect square trinomial concept to complete the square. And I've got a step-by-step here. But basically what you have to find is what the perfect square trinomial is, even though the original equation is not. And you're going to add both sides a number to make it the perfect square trinomial to solve it. But it'd be easier to show you directly what we need to do. I got a graph here, and don't worry about the graph here. I'm going to show you why we use this graph. I'm given an equation, ax squared plus bx plus c equals 0. Now it's equaling 0, which means whatever I put in for x, my resulting y will be 0. And the equation is x squared plus 14x minus 4 equals 0. Now notice x squared plus 14x minus 4 is not a perfect square trinomial. A perfect square trinomial for this would be x squared plus 14x plus 49. Because I've got here's my x squared right here. Here's my 14x, and a perfect square trinomial, it's 2 times a times b. Here's my a is x. My b would be 7, which means my 2ab is 14x. But I have a 4 here. It'd be 49. So what we're going to do is, remember, we're doing algebra. And algebra in ancient Phoenician means balance. So whatever we do to one side, we got to do to the other. So if I have x squared plus 14x minus 4, what I'm going to do is I'm going to add 49. Or first, I'll move that 4 over to the other side. Instead of minus 4, I'll move it over here. So I've got the 4 on the other side here. But then I'm going to add 49 on both sides. I'm going to balance it. I can do this. This was originally x squared plus 14x. That's a terrible 4. I apologize for that. Minus 4. And all I'm going to do is I'm going to add 4 to both sides. 4 equals 0 here. Equals 4. And now I've got x squared plus 14x equals 4. And since I can do this in algebra, because again, algebra means balance. But to do one side, I got to do the other. I'm going to add 49 here. But if I add 49 here, I have to add 49 to the other side. So what I've got here is I've got x squared plus 14x plus 49 on the one side equals 4 plus 49 is 53. And since it's a perfect square trinomial, x squared plus 14 is 49, I can rearrange this as 7x plus 7 squared equals 53. Now, as I said, algebra means balance. Whatever you do to one side, I can do the other. And what I've done here in step 5, I've just taken this equation, put it right here, x plus 7 squared equals 53. If I take the square root of both sides, again, I'm doing whatever I do to one side, do the other. So I got the square root of 7 plus x squared equals square root of 53. Well, the square root of 7 plus x plus 7 squared is x plus 7. I do it to one side, I square root of 53 is the other. So I want to solve for x. So I got x plus 7 equals 53. I'm going to subtract 7 from both sides. Now I'm left with x equals negative 7 plus 53. And I put up here, square root of 53 is about 7.28. So x equals negative 7 plus 7.28, which equals 0.28. Now, with the square root, we have to be careful here. Because I remember, my answer was x plus 7 square root of 53. And I could have the negative on the outside, square root of 53, or square root of 53. This is called this is called the principal root. This is called the negative root. No different if I had, what is the square root of 4? It can equal 2, and that's the principal root. Or it can equal negative 2, because negative 2 times negative 2 is also 4. So we have to consider the negative root as well as the principal root. Now I solved for one already. X equals minus 7 plus 7.28 is 0.28. But then if I make it negative, square root of negative 53, and then move the 7 to the other side, I get x minus 7 minus 7.28 square root of 53, which is negative 14.28. So I have two answers here. And the reason I have two answers is I am crossing the x-axis. This is a parabola. It's 7 x squared plus 14x minus 4. Remember I said in class is the largest degree dictates how the graph will look. So it's x squared plus 14x minus 4 equals 0. When I solve this by completing the square, and this parabola goes very far up and very far down. But I want you to see more close up. There is where, when I put in x equals 0.28, my y equals 0, it zeroes out, which is what we were looking for originally. There's my 0. And if I put in negative 14.28, a little bit over, you can see it's just a little bit over 14, I also get 0 for x. So this is how we complete the square. And like I said, this is a giant parabola. And you're just seeing, if I put the different scale, I've had it fairly close up. You're seeing it looks like this overall, but I'm just blocking this part right here. Here's another one right here. X squared plus 6x plus 8 equals 0. I'm going to move this over the negative 8 to the other side. So x squared plus 6x plus 8 minus 8 would be x squared plus 6x equals minus 8. I'm just rearranging this. Now, I see x squared plus 6x. How do I turn that perfect square? Well, remember, it's the 2ab, a squared plus 2ab plus b squared. My x is a, so that means x squared. 2ab, which is my 6x, which makes this, if 2ab, and there's my a, at 2 times something equals 6, that means my b has got to be equal to 3. Right here. So, and then that means to make it the perfect square trinomial, x squared plus 6x plus whatever equals negative 8, x squared plus 6x plus 9 is a perfect square trinomial, which is, like I said, it's 3. X plus 3 squared. So what I've done here, I got x plus 3 squared, I say x squared plus 6x plus 9, equals, I put mine on one side, I got to do 9 on the other, equals negative 8 plus 9. I just added 9 to both sides from this original equation here. And I balance it. And x squared plus 6x plus 9 is a perfect square trinomial, which is x plus 3 squared. And negative 8 plus 9 equals 1. So x plus 3 squared equals 1. Now I got to solve for x. X plus 3 squared equals 1 right here. And then if I do that, I take the square root of both sides, because again, algebra is all about balance. X plus 3, the square root of x plus 3 squared is x plus 3. The square root of 1 is 1 or negative 1. This is the principal root, 1, and then I'll put a p there, and then this is the negative root, negative 1. Because 1 times 1 is 1, and negative 1 times 1, times negative 1 is 1. So when I put this back in, if x plus 3 equals 1, I subtract 3 from both sides, x equals negative 2, or x plus 3 equals negative 1, which would mean x plus 3 equals negative 1, move the 3 to both sides, be negative 3, x equals negative 3 minus 1 equals negative 4. So, x can have 2 answers, where it equals 0. X equals negative 2, and x equals negative 4. And what we got here is, you can see the graph right here, at 0, 4, 0, there's negative 4, and there's 0, it equals 0 right there, which is one of my answers. I put negative 4 for x, and I get 0 on the y. And if I put in negative 2 for x, I also get 0 for the y. Again, and this is a real deep parabola, and you're just seeing a little part of it like this. You're just seeing this little part of it, which is why you see these lines. Now, if all else fails, we can use the quadratic formula, which I've been using for almost 40 years. That's why it's memorized to me. This will work for every possible equation, but it's also the longest. It's usually if you get some kind of crazy trinomial and you can't factor it out through different methods, which are, the AC method or PQ method we talked about yesterday, or perfect square trinomial, pyramids of squares, completing the square, you can always factor this in. And remember, it's a ABC formula. The A refers to the coefficient here on where the x squared is. The B is the second factor, where it's a single degree, and then the C is the constant. And you got to figure out your A, B, C, and R, but it's always got to be put in from highest lowest degree. The formula is negative B plus or minus square root of B squared minus 4AC all over 2A. The difficult part of this is figuring out what A, B, and C is. So here's my A, which is 5. Put it right here. It's attached to the x squared. My single factor x, 8x, which is my B. And then my C is my constant, which is right here. And I'm just going to plug this in. I've gone step by step here, but I'm sure you've done this before. So when I put this in, I put in A for B. That makes this a negative A on the outside, plus or minus the square root of B squared, which is 8 squared, which is 64. Minus 4AC, which is 4 in this case times 5 times 3. And 4 times 5 is 20 times 3 is 60. So we get negative 8 plus or minus square root of 64 minus 60, which is all over 10. I forgot the A, 2A, which is 2 times 5, which is 10. So you get negative 8 plus or minus square root of 4 all over 10, which is negative 8 square root of 10. Square root of 4 is 2. Negative 8 plus or minus 2, because we got the principal and the negative root, all over 10. Well, let's look at the first one. Negative 8 minus 2 is minus 10, all over 10, which is negative 1. So this is this one right here. If we just do the minus part, this is my answer. And we do the plus part, negative 8 plus 2, we get negative 6 over 10, which is 0.6. And that means when I put in negative 1 for x or negative 0.6 for x, I will get a 0 for my y. And I can prove it right here. Again, this is another long, detailed parabola. But there is my negative 1 right here. And then here's my negative 0.6 right there. So you can see the 1 is kind of hiding behind it. I got it right on there. And then there's 6/10 right there. This kind of proves you graphically, when I put this equation in decimals, I do get those zeros for y at those x's. Again, the quadratic formula works for any overall trinomial equation, but I only like using it as a last resort because a lot of them are difficult otherwise.